This tutorial shows how to create the horizontal tail of the L23, and instead of doing it purely based off dimensions like I showed with the wing, we're going to do it by tracing a painting. I have another video that you can find by searching insert painting or drawing that'll show you how to get the drawing in there. Once the drawing is in, we're going to follow essentially the same methodology of the wing, where we draw an outline using lines and dimensioning them will create references to which we can create 3D geometry by translating and scaling an airfoil. In this, I've already created the airfoil, as you can see in another video how to do that if you haven't seen it already. Inserting an airfoil from coordinates using a cell macro. So the root airfoil of the horizontal tail is already in there, which I'm using as I projected that into the plane. That's the yellow line you see there. Now, creating parts based off of drawings is more of an art than a science. And this is made especially difficult because 3-view drawings that we are based off of are generally not to scale. And if they are to a scale, they use different scales in different dimensions. So for example, the ratio of real life to drawing in the X is not the same as the Y, which can create a bunch of problems. And you can scale pictures using Photoshop or something similar to get them improved, but really it can be a big headache. So one of the things you need to appreciate when you're creating parts based off of drawings is that better is the enemy of good enough. So really you're just looking for something that is close. It doesn't have to be perfect. So again, if you haven't watched the tutorial on how to create the wing, that might be a good place to follow along what I'm doing by making these sketches, or making this sketch here. Right now we just put in the 25% chord. And we'll put in that span dimension based off of what you can see there in the drawing, 14.67 feet divided by 2. And that matches up fairly closely, so we'll leave it as it is. And now we're going to create the curving taper at the tip, which will require your best artistic abilities. So we put in a spline, we'll set the endpoints tangent to the lines that they connect to. Set tangency, and then we'll just move our control points to try and get some sort of decent representation. I put in a dimension here to offset, so to make sure that point stays on the inside of the what would otherwise be the tip chord, which doesn't necessarily mean it won't bow out, but there I think we have something that looks good enough. 2 favorite words. And then we'll trim using this quick trim eraser tool. Here we go. To remove the other lines. And the escape key is your friend when you start moving something that you don't want to move. Remember that. And that'll give us our leading edge offset, or leading edge sweep, sorry. And there were a couple things that should have been construction objects that were not. We're hiding the edge line at the end because that's where the airfoil goes. So really all we want out of that drawing is the leading edge contour, which can be used as a guideline when we do a multi-section surface. There's a reference dimension for what the tip chord should be, which is significantly smaller than the approximation that you would use for wing area if you're just using the taper ratio wing area root chord relationship. But to create in 3D space the visual, we're going to make it smaller. So we'll call it tip short. And we'll create the geometric set for tip airfoil, which we'll put in a translation along the half span Y direction of the root airfoil. And sometimes you need to go in the formula, make it negative, and then we'll translate it in the X direction to get the leading edge offset, the tip short leading edge offset, puts us right on the back edge of that leading edge contour. Ideally those points should be coincident. And then we'll create a point on the leading edge of that airfoil in order to scale this according to tip chord short divided by root. So that's the taper ratio. And we'll add a trailing edge contour by creating, let's move into the HT geometry set before doing that. Now, geometrical sets can really help to keep your tree organized, so you want to make sure you use them as much as you can. So we're going to, this is how you change geometrical set. Right click on it, change geometrical set, and select the set that you want to move it to. And now to create the multi-section surface, select your two sections and your two guide curves, and check that out. That looks good. And to fill in this airfoil here, we will use the fill tool, no pun intended, which is the little baseball cap looking thing. When you have a little indicator that said closed surface there, which was in teal that you saw, that means it should work. Or closed contour. And then we'll join those two together using your puzzle piece icon. There we go. And we'll rename that right horizontal tail skin. Naming things is your friend. Do it. naming things in geometrical sets. Don't get lazy. It'll make your life easier later. And that's how to create the horizontal tail. And we can